Welcome everyone. Today I'm going to show you the prototype of Fido IoT Smart Agriculture. So in this video we're going to show you the step by step of the prototype. So be right here with me. So let me take you through the system. In the first place we have the soil moisture sensor here. Soil moisture sensor. It's going to sense the water content and now switch on the pump automatically depending on the soil content, the water content in the soil. We have DHT 11. This is a humidity and also a temperature sensor. It's going to sense the humidity and temperature around our prototype, our system, which is the farm. So we have the ESP8266 version 1. This sensor is a Wi-Fi module sensor. It's going to send our readings to the database of our system. So we have the microcontroller here. We are going to, all these are connected and through this microcontroller, and we have our power source here, power bank to power on the Arduino, and we have the pump there which is going to take water and supply it to our prototype garden. So we have the liquid crystal LCD here, the potentiometer. We can control the view of our readings. So I'm going to switch on the system and we are good to go. So I'm going to switch on here system. So Smart Farm Project by Kelvin. From there, after some seconds, then after 5 seconds, then we are going to see the readings. So we have humidity in percentages, so the 39% humidity. So this is measured using this DHT11 sensor. So we also have the temperature measured in degrees Celsius. Now it's 27 degrees Celsius, and we have the soil moisture of our prototype garden. As you can see, the soil is dry, so the soil moisture in percentages, it is 12%. So the system is going to switch on the pump when we have less than 12. When we have less than 50% of water in the soil. When we have more than 55% of water in the soil, then the system is going to switch off automatically. So that is how the system works. So we are going to power our system and we are good to go, and that is our prototype tank. So water will be coming from there, and we are going to water our plants. And in our prototype tank we have 6 liters of water there. So yeah, okay, so let me switch on the whole system. Thank you. All right, we're going to switch on our system. So from the liquid crystal, we're going to see the soil moisture, and if it's less than 50%, then the pump is going to automatically switch on and begin watering our plants. When it's watered, when it's more than 50%, 55% of water in the soil, then the system is also going to send, the soil moisture sensor is going to send data to the pump, and the pump is going to switch off automatically. So good to go. All right, switch on the system and Smart Farm Project by Kelvin. After 5 seconds, then our system is ready to go. All right, see, soil moisture is less than 55%. That is why our pump has started watering our plants. So we have this sensor is connected to the soil moisture sensor. It is for measuring the soil sensor, the soil moisture in the soil. So alright, then you can see now water is coming out from our pump automatically, because our soil moisture sensor is reading less than 55%. So we assume the pumps will be already connected, but because this is a prototype, that is why you see it like this. So if water starts coming in, you're going to see after now there is 67, because it's more than 55% soil moisture in the soil. That is why our sensor has sent data to the pump to switch off. Now we are good. So this autonomous irrigation system is going to help farmers in various ways as explained in the documentation. So now we have 74%. That is why our pump has automatically switched off. So if I can remove this soil moisture sensor and it's now now it's dry, then if it's less than 55%, the soil moisture reading here, then our pump is going to switch on again. So now you see the pump is off and we're good to go. So these readings will be sent to the database of our system using this module, the ESP8266 Wi-Fi module. So data will be sent to our database. So now this is how this Wi-Fi module works. It's connected to the strongest Wi-Fi network available. In our case, I already sent the AT command. I already programmed it to be connecting to our Wi-Fi called KCM3, which is already connected. That is why you see the red light here just still like that, because it's working and it's sending data. So data is not continuously sent, but you can program it to be sending the data in after some seconds. Like now, I have programmed it to be sending data after 17 seconds. So the data will go to the cloud, and after that we can send the data to our database in a local host, and we are good to go. So we also have a potentiometer here. We can control the liquid crystal LCD, and as I already explained, you can control this thing, so you can increase the sensing of the moisture sensor here using that blue and gray. You can increase the sensing of water soil moisture. Now you can see you have two lights there, dual LED and in analog input LED. This is because now data is coming from the sensor here, and it's sending data to the Arduino to tell it that no, do not switch on, because the water is enough and the pumps must switch off. So basically that is how Fido IoT Smart Agriculture Prototype is working. Thank you.